Hello and welcome. So today we will do decision tree. So the example that we will try out using decision tree is predicting a game of cricket. So we will see how we can predict the outcome of a game of cricket using a decision tree. So I hope this will be interesting. So let's get started. So here we have a table of India's last few T20 matches against selected countries, that is Australia, New Zealand, Bangladesh, and England. Okay, so we will try to predict from these records of win and losses of last 30 matches against involving these countries. So we will try to predict if now a match happens between any of these countries, what is India's probability of win or loss, or whether India will win or lose. And the factors we consider are the opponents, of course, which is one of these four countries, where the match is being held, which city, whether India was a toss winner or loser, and whether India batted first or batted in the second innings. Okay, and here are the results, win or loss. So I have already transformed this column as a 0 1 in a categorical column using 0 1, where that is 0 signifies India batted in the second innings and 1 signifies India batted in the first innings. So we will have more on this conversion techniques later on, but for now we will need to convert another column also, that is the CT column. Okay, so I convert it into a column called home ground. So if it's played in India, we are considering 1, and if it's played outside India, we are considering 0. So this is a bit simplification. So for our initial understanding of decision tree, we will take this simplified scenario. Okay. Let's see, if we don't consider any of these factors, what is the percentage of win of India against these countries. Okay, so if you see the probability of win, it's 15 out of 30 India has won, so it's 50%, right? So there's a lot of uncertainty. Okay, so what we tend to do is to reduce, we need to find factors among these so that this uncertainty gets reduced. So we cannot predict, we can predict a win or loss with only 50%, which is like a coin toss. But what we will try to do is to find factors involving this so that this uncertainty gets reduced, and we can say that India will win or lose with a higher accuracy. Okay, so first we need to find a measure of this uncertainty, which we consider. There are many kinds of measure, but in this video we will consider the entropy. Okay, so entropy is measured as the different probabilities, that is negative of the probability multiplied by the log of that probability. In this case we have two conditions, so win and lose. So this is the probability, this is the entropy. It measures the amount of uncertainty in this information. So if you consider this as an information, that's 0 1, the win and loss, so it's the amount of uncertainty will be given by this measure. So if you see, it's probability of win into log probability of win, minus that is a summation of the negatives actually, and probability of losing multiplied by the log of probability of losing. If there are more conditions draw, we had to continue this. Okay, so what is, if you find this both are 50%, if you put 50% over here, you will find this, that is the entropy is 1, which is very high, and in fact it is the maximum entropy possible in case there are two conditions. So because and we can understand, like it's 50%, right? So yeah, it's 50%, that is, it has the highest amount of uncertainty. Okay, so now let's see if we can find a condition by which we can reduce this uncertainty of information, and we can say with more certainty one of these conditions. Okay, so what do we do now? Suppose we can consider a filter from one of these features that we are considering, that we have, like opponents, toss winner, bat first, home ground. So let's consider bat first. So it can have two conditions, right? Of course you can elaborate it to more conditions, so it can be 0 or 1, right? So these are the tables for when India batted first, and these are the tables when India batted in the second innings. So if you see now, for this one, for the table on the left, what is the entropy? Okay, this we know the entropy is 1 for this table, and for this table the entropy is 0.98. okay, a little less amount of uncertainty, and this is 0.96. so if we split by this, are we having a gain on this entropy? I mean, we have to consider both the splits in that case. So this is the formula to calculate the gain, that is this entropy minus the summation of these two entropies, and we are seeing that the gain is 0.03, some amount of gain. Okay, so let's consider another condition now. Let's consider the condition of toss winner, and I have split the table into two, where India has won the toss and India has lost the toss. You can see here all toss wins, and here all the toss losses, and the entropies are 0.9. so you can see here the entropy is quite less. Okay, and you can see the gain is 0.12 here. Okay, similarly we can consider two other scenarios, that is, in case if you see in a similar way, if you consider home ground, the entropy gain is 0.07, and if you consider the opponents, it is maximum now, 0.14. of all the four gains, this is the maximum. Okay, so we need to choose, so of all the four criterias that we have, bat first, home continent, home ground, opponents, and toss winner, we think that this is the best to split and we are getting the best gain, so we choose this condition to split our tables. Now for each of these conditions, like for Australia, again we have to consider which of the like whether, again we see here the entropy is 1, here 0.92, 0.6 and something we can calculate. So now from each of these we can see whether we can, by choosing the others, we can reduce it further or not. Okay, now let's we have to take each of these cells now. First let's consider for Australia, when opponent is Australia. And if you again consider each of the gains after splitting by Australia, you will find out that toss is the next most important feature that gives the highest gain. Okay, and in fact if you split by toss, and if you see toss losses, if you with Australia, and toss is lost, then you can actually have all conditions as win here, so we can stop over here. So we can say that if it's a match, if it's a T20 match against Australia and India loses the toss, India is probable to win with 100% probability based on the last 30 matches. Again, but if it's won, there are a mix of win and loss, and we can find another condition from the rest of the two, and we see if it's home ground and whether it's home ground or not. So if it's a home ground, we see mostly win, and we see if it's not a home ground, it's mostly lose. Okay, so next we can go further by putting the bat first condition, and we will see that there is not much reduction. Okay, so we can see we can say if it's if India wins the toss and it's a match against Australia. So if it's a match against Australia and India wins the toss, and if it's played on home ground, we can say that India is mostly winning. Okay, you can calculate the percentages based on those filters, and on the other case, if it's away, then it's mostly a loss. Okay, so we increase our probabilities and accuracy of prediction by splitting it on conditions. Now we move on to New Zealand, and we can go back here, but here we have got very high, very low entropy, and all are actually the entropy is 0 over here, because all the probabilities are win. Okay, so now if we go to New Zealand, and we will find that it almost chooses the same options again, so we will skip that and we will go to Bangladesh. So in case of Bangladesh, if we see that if we split using the bat first, India has a higher 100% win if India bats in the second innings, whereas the win percentage is a little less if India bats on the first innings. Okay, So this is how you can continue to build a tree. So there are various stopping criteria. So one is like this: if you have all the conditions of the same class or the same factor that you are trying to predict, or you can choose a depth of the tree by which you can decide to stop, or when all the divisions are exhausted. Okay, some other important facts, like if we go back to our table, the initial table like this one. So if you see here, it's a categorical column, right? If it's a continuous column, probably you might to reduce the variance in each of the columns based, I mean, you might need to you would like to choose the split in such a way so that the variance in this column reduces. On the other hand, if these columns are continuous rather than categorical, you might want to split it by the mean value, or might want to choose a value first, might or might opt to test on various splits or various split values where the entropy reduction is minimum. So there will be a competition within the column itself, or you might want to split it, or you might want to categorize the column based on certain range of values. Okay, so these are a few things. This is how a decision tree more or less works. There are more complex advanced techniques on decision tree also over and above this, but this is basically. So this is how you can predict by building a decision tree. Okay, so hope you had an understanding of decision tree, and in scikit-learn you would get a decision tree classifier. You don't need to go by this, you can just use the library to do a fit and predict, though the algorithm they use is different from what I have used. It's an advanced algorithm. Okay, thank you.